Hello guys, good afternoon. You are welcome to my YouTube channel, The Explicit Tutorials. As you all know, I'm Dr. Joseph or Mr. Explicit. As you watch this video, do subscribe so that when I upload subsequent videos, you would be notified by YouTube, alright? So in today's class, we have done fundamental derived quantities as well as dimension already. Okay, but in today's class, I'm going to be showing you how to know if a quantity is dimensionally correct or incorrect. Alright, in doing so, there are three things you must commit to memory. There are three things you must commit to memory without forgetting any of these three. One, in deducing the dimension of a particular quantity that is trying to know if it is correct or incorrect, whatever you have by the left you must have the same thing by the right. Whatever you have by the left, you will have the same thing by the right. For example, if I'm having by the left LT minus 1, it means that by the right, I will also have LT minus 1. But if I'm having LT minus 1 by the left, and I'm having LT or LT minus 2 by the right, it means what I've done is wrong. It therefore means that the dimension of that quantity, it means that that quantity is dimensionally what incorrect, because what I had by the left was not the same as what I have by the right. You get? So please, when a quantity is dimensionally correct, it means that whatever you have by the left, you have the same thing by the right. Okay. Then number two, you must neglect figures. 1, 2, 3, 4, 5, 6, as the case may be, must be neglected. In deducing the dimension of a particular quantity, you do not put figures into consideration. You neglect it. Number three, constant. Certain constant like sigma pi should be neglected. I'm not saying all constants. For example, Newton's universal constant should not be neglected because it has dimension. Acceleration due to gravity, which is big letter, small letter g, it has a dimension, so it should not be what neglected. But you see pi, sigma, and all that, they should all be neglected. Okay, please, these are the three things you must know before trying to know if a quantity is dimensionally correct or incorrect. One, whatever you have by the left, you have the same thing by the right. Then number two, neglect figures such as 1, 2, 3, as the case may be, and certain constant like pi and sigma should be neglected. But the one thing is certain, the formulas that exist in the world of science or in the world of chemistry or biology, they are dimensionally correct. For example, the three equations of motion, they are dimensionally correct as postulated by Sir Isaac Newton. All right, you know he was the one that discovered motion, all right, and force. Okay, that is why the unit of force is what Newton. It was named after his own name. You understand? So all the three formulas of all the three formulas or all the three equations of motion are dimensionally what's correct. Okay, apart from just saying it, let me teach you how to go about it. Don't forget, whatever you have by the left, you must have the same thing by the right. So let's jump into business. Don't forget that the three equations of motion, the first one is v equals u plus at. There's the first equation, but you and I know that v is the final velocity, while u is the initial velocity, and initial velocity when a body accelerates from rest, it is what, 0. So you are considering this as what, 0. You are not using it at all. It therefore means that I will not be having v equals what, at. Is that what we have? So v, which is velocity, is lt minus 1. Acceleration is what, lt minus 2 times what, c. That is this for this for this, and this one is for this. Alright, so what do I do next in order to prove this, or in order to actually do justice to this is what I'm going to do. So lt minus 1 equals, this is it, you have L here, so there's an invisible plus 1 here, so t minus 2, that is minus 2 plus 1, I have what, minus 1. So I have t minus what, 1. So the first equation of motion is dimensionally correct. I believe that is clear enough. Whatever you have by the left, you should have the same thing by the right. Else, what you have done is dimensionally incorrect. The second equation of motion, which is S equals ut plus half at squared. Half at squared. Do not forget what I said initially, that this guy is always 0, so everything here is 0. And this half is to be neglected. 1 over 2 is to be what? Neglected. In some cases, if they want to confuse you, in place of this S, they'll give you X. But once you are given X, they will tell you that X stands for what? Distance. So S is equals what? AT squared. Very easy. S is distance L. We are using S. No, don't forget we are discussing dimension. So S is length, that is distance. Acceleration is what? LT minus 2 times T raised by what? 2. Right? So I have L equals minus 2 plus 2 is nothing. So I have what? L. So L equals L. It means that the second equation of motion is dimensionally what? Correct. Now let's check the third equation of motion. The third equation of motion is V squared equals U squared plus 2AS. Don't forget that this guy is 0 and we're also neglecting what? A. I'll now be having V squared equals what? AS. Very easy. Now don't forget that velocity is change in displacement or distance with respect to time. It's raised to power 2 becomes AS. So I'll now be having L squared over T squared. Acceleration is LT minus 2, then distance L. Please, this S here does not stand for time, seconds, no. It is distance, okay? So if this T goes up, I'll now be having LT raised by what? Minus 2 equals L. As L times L is L squared, then T minus 2. So the third equation of motion is also dimensionally what? Correct. Okay, sorry. There's 2 here. So the 3 equations of motion are dimensionally correct, okay? Let us jump into other quantities. Prove that change in impulse is equal change in what? Momentum. Change in impulse is equal change in what? Momentum, okay? Okay, let me use this sign. Change in impulse equals change in momentum. So impulse, don't forget that impulse is force times time. Momentum is mass times what? Velocity. Watch. Impulse is force times time. Momentum is mass times what? Velocity. Force is lt minus 2 times what? This t, right? Then big letter M times lt minus 1, because velocity is lt minus 1, okay? So I'll now be having M. So there's an invisible plus 1 here, right? So plus 1 minus 2, I have what? Minus 1. So lt minus 1. If I should combine this, I'll have M lt minus 1. So change in impulse is equals change in what? Momentum. That is second law of motion. So it means that this equation is dimensionally what? Correct. Because what we are having by the left is the same as what we have by the right. Let's jump into others. I have F equals what? mv squared over what? R. What is this formula? When do you use this formula? When you ask to calculate for the centripetal force. Don't forget that centripetal force is that force required or needed to move an object in a circular what? Radius, which is F equals mv squared over R. R is the radius, V is the velocity, M is the mass, and F is what? The force. Okay? So first and first, I'll cross multiply. I'll be having F arrow equals mv squared. M, that is, this time is this, right? So don't forget that force is mlt minus 2 times L, which is the distance, mass times L over T, all raised by what? 2, because of this power here. So I'll be having M. So L times L is L squared, then T minus what? 2, right? So M times this, what I have here, I can, L times L raised by 2 is what? L2 over this raised by this is what? T2, right? And you agree with me that if this thing goes up, it becomes LT minus 2, right? So I'll put here LT minus what? 2. So if I should combine it, okay, if I don't want to cancel that, so what I have here, I'll be having ML2T minus 2 equals is that what I'm having? Am I making a mistake here? So this times this, wait, force is M, okay, radius equals, okay, yes, look at the mistake here, I was wondering. That's L squared 2. I'll be having L squared T minus 2. So whatever you have by the left, you must have the same by the right. So what I've just done is dimensionally what? Correct. What about the relationship between linear velocity and angular velocity? Don't forget that linear velocity is angular velocity times radius. And angular velocity is measured in rad per second. And angular velocity is angle over time, or radian over time, which is also angle over time. So linear velocity is LT minus 1. Angular velocity is angle over time. And angle is what? Dimensionless. I'll just use 1 over what? T. Radius is what? L. Right? So I'll be having LT minus 1 equals, if this T goes, it becomes what? Minus 1. So LT minus 1. So linear velocity connecting it with angular velocity times radius is dimensionally what? Correct. So whatever you have by the left, you should have the same thing by the right. That is why they say you deduce carefully if a quantity is dimensionally correct or incorrect. Okay, so it is very, very important. Now, what about, let's prove you have T equals 2 pi, then L over what? G. Now, this is the formula used when you are calculating for the period of a pendulum bulb. T is the period, L is the length, and G is acceleration due to gravity. Don't forget that you have to neglect this guy. Once you have neglected this, in order to cancel out this big root, what do? Square both sides. So all squared, all squared. So these two will cancel out this square root here. So I'll not be having T raised to power 2 equals L over what? G. That is for that. So the next step is to what? Cross multiply. If I should cross multiply, I'll be having T squared G equals what? L. True or false? True. So T squared times G, which is acceleration due to gravity, LT minus 2 equals what? L. Right? So plus 2 minus 2 is nothing. I'm left with L, so equals L. So L equals L is dimensionally what? Correct. Okay, so let's also deduce for, let's try this out. T equals big root V squared over 2AX. 2AX. X here represents distance. So how do I go about this? Let's check it out. Don't forget you have to neglect this guy. It's not to be considered. Because of this big root, you have to square both sides. Very important. Don't forget that. So this will go to this. I'll be having T squared equals V squared over what? AX. What do I do next? I'll cross multiply. If I cross multiply, I'll be having T squared times AX, that is T squared AX equals what? V squared. V squared. So it means that T squared times A is LT minus 2. True or false? True. Times L, which is what? Distance. Hope you are following. Then don't forget that we had that V squared is L squared, then T minus what? 2. I think we did it just now from this place, and we had L squared T minus what? 2. So what do we do next? L times L is L what? Squared. L times L is L squared. Then plus 2 minus 2 is nothing. So I'm having L squared T minus what? 2. So it means that what have this quantity T equals big root V squared over 2AX is dimensionally incorrect, because by the left you're having T squared equals L squared S squared T minus 2. What is this T minus 2 doing here? That is what makes it incorrect. Okay, so please just don't forget, this is how you go about it. It is very, very simple. Very, very, if you can just remember three things. You must neglect figures. You must neglect constant like pi is 6 sigma. You must know that whatever you have by the left, all right, should also appear by the right. All right, if you have it by the left, maybe m, and you have it by the right z, it means that what you have done is dimensionally incorrect. So that is how it is. Please let me get the ball back. So don't forget, I believe I can rub off this place. Do you know that Boyle's law has the same dimension as work, energy, torque, and movement? Boyle's constant has the same dimension as work, torque, moment, and what? Energy. Torque, work, moment, and energy have their formula as force times what? Distance. And Boyle's law states that the volume of a given mass of a gas is inversely proportional to its what? Pressure, provided that temperature is kept what? Constant. Boyle's law states that the volume of a given mass of a gas is inversely proportional to its pressure, provided that the temperature is kept constant. So how do you go about it? So this V equals K over what? P. Alright, so if I should make K subject formula, I'll be having PV. That is this the constant now, right? So it means I'll be saying PV equals work done equals moment equals torque equals what? Energy. So I'll pick one of the four. So PV, which of them should I pick? Let me go for torque. This is P times V equals torque is force times what? Distance. Force times distance. Pressure is force over area. Then times what? V. Then F times what? S. Okay. Force is, that's pressure is force over area times V equals F times what? S. Let's continue from here. So force, don't forget force is mLT minus 2 over area is length times breadth. Yes, we know. But in dimension, we say L times L, and that will give us what? L squared. The volume, we know that volume is length times breadth times what? Height. But in dimension, we go with length times length times length. I'll be having what? Length what? Cube. And don't forget force is here mLT minus 2 times what? L. Right? Because this L stands for what? Distance. So if two L's cancel, if two L's are taken from this place, I'll be having mLT minus 2 times what? L. Then mLT minus 2 times what? L. So if I should merge these two together, I'll be having L times L is L squared, T minus 2 equals, so L times L, this M, L times L, L squared, then T minus what? 2. So Boyle's law is dimensionally, Boyle's law and Charles' law have been proven to be dimensionally what? Correct. So this is how you go about it. What about Newton's universal constant? You know that Newton's universal law states that the force of attraction between two masses m1 and m2, let me write it here, the force of attraction between two masses m1, m2 is directly proportional to the product and inversely to the square of the distance that separates them apart. Newton's universal law states that the force of attraction between two masses m1, m2 is directly proportional to their product and inversely to the square of the distance that separates them apart. Alright, so F becomes big letter G m1 m2 over r squared. So this big letter G is called Newton's universal constant. So we are trying to check if if we are going to, if this stuff is dimensionally correct or what not. It is very easy, you just follow it step by step. So what do I do next? I'll cross multiply. I'll be having f arrow squared equals g m squared. Let me just use m squared instead of writing m1 m2. All right, so I want to make, okay, let's check. I want to make g the subject formula, but okay, let me just do it that way. Let me do that way for a better understanding, please. All right, so that is how it is. All right, so g is equals, so it means that we are trying to deduce for the dimension of what? Newton's universal constant. And I told that it is not all constants you should neglect. There are some constants that have dimension, so they should not be what? Neglected. All right, so I'll now be having mLc minus 2 times L squared over m what squared. Is that what I have? Yeah. So if I have 1m, cancel out 1m, I'm left with 1m. So g is equals L cubed, then c minus 2 over what? M. So g is equals m minus 1. Yeah, because if this m goes up, it becomes minus 1, then L cubed, then c minus what? 2. Please, there's a way they bring questions sometimes. They'll give you mx, ly, and c what? Z. They'll tell you to calculate, they'll look for the value of x, y, and z with respect to a particular physical quantity. It could be electromotive force, it could be Newton's universal constant, it could be power, it could be work. So if, for example, the question was related to Newton's universal constant, it therefore means that x is minus 1, because x is occupying the position of minus 1, then y is what? 3, and z is what? 2, minus 2. So at this point, we call it a day. If you have learned something in this class, endeavor to subscribe, like, share, and comment.